Yeah. So so DaemonSet is a pod which gets automatically installed on each of the node. Now, why would you need such pod? Generally, you need such pod for various things. Like in one of the things which the companies do is they have this separate standalone machines running. If you're on cloud, then it might be EC2 instances or EMR instances, and they're generating a lot of logs. Now they might want to put all these logs which applications are generating into Splunk, for example. So different people have the different log aggregation mechanisms. Splunk is one of the most widely used. Or you have this Kibana, I forgot that, Elasticsearch, Kibana, and that stack also. So whatever it is, so you might idea is that on each machine, whatever logs are getting generated, you might want to put those logs into Splunk. So we call those log forwarders. So now when someone is spinning up a new pod, that person need not worry whether about the log forwarding and all. So by default, a pod which is forwarding the log should automatically be created there without even user knowing it. That's one use case of this DaemonSet. There could be other use cases where they want to check, if the logs contain some, PII information or any information which should not be logged, for example, password or social security number or things like this. So the pod is checking this constantly on the log files, and whenever it detects such things, it just sends an alert or some notification or something. So this is another example of why you might want to have a default pod on each of the nodes. So that default, the way to do this is DaemonSet. So this example, what is trying to do is, and also there will be one replica of this pod on all the nodes. You cannot tell DaemonSet to have two pods on the same node. By default, it will create one pod. If this pod gets deleted, then it will immediately start the same pod on the same node. So you have a DaemonSet. You have 3 nodes, and you have one replica set, which we were just discussing. It has 6 replicas. For example, 2 here, 1 here, and 3 here. And your DaemonSet will have only one. You can't give the replicas in the DaemonSet. It will by default have one replica on all the ports. So that's about DaemonSet. I'm just reiterating what I said. A pod on each node if you want, use DaemonSet. DaemonSet creates as many pods as nodes. DaemonSet doesn't have notion of desired replica set like you have in replication controller or in replica set. Design replica, it should, it's written wrongly. It doesn't have the notion of desired replica like you have in replication controller and in replica set. Why? Because it's not needed. It automatically ensures that pod, a pod, DaemonSet pod is already there on each node. You could very well have the, sometimes you don't want DaemonSet on certain pods. For example, some pods are generating the financial data, which is even log also has, logging also contains some data which should not be on the Splunk or should not be, it should not be even looked at. So on those nodes, you don't want DaemonSet to be running, for example. So for such use cases, you can have the node selector in the DaemonSet also. And we'll take an example of this. So if node is going down, then DaemonSet does not start elsewhere. So in this example, if this port, DaemonSet port goes down, it will start. But if this complete node itself has gone down, then DaemonSet will not worry about, that it had 3, ports running. Now 1 port it has to restart. It does not worry about that because the node itself has gone down. If a new node gets started, of course, DaemonSet will, spin up there also. So this is what I'm saying. New node coming up, DaemonSet deploys a new pod instance on it. So by default, it will run on each node, but one can use node selector to run on the certain nodes only. So this is what I just explained. So take an example. If I want to run on the certain nodes, how does that work? So use node selector property. So there's a node selector. I think we had discussed in the past ones. So this node selector property in the port template, which is part of DaemonSet definition, we should use that property. So what is node selector? It defines the nodes. The DaemonSet deploys the port to. It should not be node. It defines a node. The DaemonSet deploys the port to. DaemonSet will deploy to even unscheduled nodes if those are node selector. So what are unscheduled nodes? It preventing pods to get deployed on them. For example, in your Kubernetes cluster, there are some machines which are where no pod should be deployed. Those are called unscheduled nodes. But those nodes have a node, and we'll see how you can label a node. So those nodes have certain label, which is matching with the label of node selector in the daemon set. So in that case, the daemon set pod will get started there also. And why it's reasonable if daemon sets are used to run system services, even on unscheduled pods. For example, if the unscheduled unscheduled nodes are generating the some logs by running, which are some default applications which might be running there, you might want to look at those logs as well. Or some pod, I don't know, just a hypothetical example, generally use Grafana and all those things. If you want daemon set to monitor some system metrics, memory or hard disk or something, so you might want to monitor on the unscheduled nodes also. This example, you have node 1, node 2, and node 3. In node 1, you have this node selector. This, remember, this label is on the node, not on the pod. So node has label app name sales, app name HR, and app name sales. And you have a daemon set. Daemon set name is app monitor, and the node selector in the daemon set is app name equal to sales. Now, because it's app name equal to sales, it will be set here on these node 1 and node 3. Because node 2 doesn't have app name sales label, and this is the app monitor, right? So the pod app monitor here, pod app monitor here, and on the node 2 there might be some other pod running, but it will not have the daemon set. I will show you some example of this, live example of this, but let's understand the daemon set definition, daemon set YAML. This is a link which has good amount of information. I did not put all of this in the slides. It has more than what I will be covering in the slides. It's just 1 second. 1 second.
Obviously, now.
Right. So a daemon set is like replication controller only, but it skips the Kubernetes scheduler. Kubernetes scheduler is basically, we discussed when you are trying to, spin up a pod or application controller, the scheduler decides, you have these 3 replicas of this pod, then which are the nodes over which this pod should be started. So that's a scheduling process. For daemon set, you don't need that scheduling process, because by default on each of the, pod, or at least from the nodes which have the node select that node label, this daemon set pod will get started. So this is a daemon set YAML file, and we'll go into this. So you have spec.selector and spec.selector. This is the pod selector, right? This name spec.selector match labels should match in the template. You should have the label, same label. So these two are same, correct? And so this is what I've described. So it should match the spec template metadata label, which is this. So these two should match. It is needed that daemon set will be on the pod created from spec template, and on the same pod rest of the settings is to be applied. Yeah, because even if you give the node selector, that node might have different pods running, more than one pod running there. So in that case, you want to apply this to only the pods on the same node which has these labels. So spec template, we have discussed the spec template. It creates a pod with this template. It's needed and represents pod. Same schema as pod without kind or API version. So it's the same as pod, but you don't find kind or API. It's just supports information. All is inside the template. Spec template, spec node selector. So which is this. So daemon set will run on the nodes with this label. Spec template, spec image. This is a daemon set image. Spec templates, it's a container image. I forgot to put container here. So it's a container image. So I have created a new container. I will walk you through what I am trying to do, what I am trying to demo here. But I have created a new Docker image called log checker. What that log checker does it's very crude, very basic thing. It looks into the log file, and the log file is also hard coded there /tmp/ tips.log. It's looking to that log file, and then if it finds SSN or password, like a really word called SSN and a word called password, then it just logs it. In reality, you might be, sending emails and notification, but this is very crude and very basic. Just for timing, it just logging in. Now, there are a couple of other things which are happening into this. One thing is happening is that I'm doing a volume mount here. So, on my host path, I have this user ID /user / my username, and it's being, I'm naming this as temp. Then in the container, this temp I'm mounting as a /tmp1. So basically, if you go to the container, you log into the pod, you will see /tmp1, which is basically showing you the files which are inside this folder on your host machine. And we'll see an example of that. Correct? Now, what happens? So if you think about it, right? Because a daemon set has to match a node if you give node selector, and within that node, it has to match ports because you are given these labels. Once it matches the port, then on that node, sorry. So it will start a pod with this label, but it has to match that. It has to match that node. So we'll see right now. We'll, in our demo, we'll change the node selector, and we'll make this. We'll have the node have the same label. We'll change the node to have the same label which you have given in the node selector, and we'll see the if the daemon set is getting started there or not. Okay. So
Sandeep, I have a question. So you told daemon set.
One second. Right. So now, so this log checker code is here. You can give your GitHub ID. I can give you the access. And what it does is, so let me open this code. So this is a controller. Actually, I already have it open. This is the controller, and all this controller does is exposes a /check endpoint, and it calls the security checker, which is very crude security checker. All it does is, I have hard coded this. Generally, you don't hard code, you pass as a configuration, but I wrote it very quickly, so I'm just hard coded for for convenience. So what all it does is it looks into this log file, and the moment it finds SSN or password, then it just log the information, log.c a security breach or something. Generally, you send email, pagerduty alert, or whatever mechanism you might have. Generally, that's what you do. But for our crude checker, we are just logging it, correct? And we'll see that as in the demo. So, so this is our log checker services. Now, what happens is this is the flow. Our application which we are using for so far, like it's a tips application, like /tips we use, right? It writes to some, it writes logs to /tmp/tips.log, correct? And the same log file is being checked by our security checker, correct? Now, the way I have done is, as I showed you here, on this daemon set, I'm mounting a volume, which is pointing to this folder, and it is mounted on the /tmp location on the daemon set. In my application also, let's see, in my application also, I do the same thing. So I have pod, which is again, this is a new pod which I have, new YAML which I have created. In this pod, I am mounting the same, path onto the pod also, right? So same path is mounted onto the log checker. Same path is mounted onto the my pod, which is doing the real business application. And this pod is generating a log file, and our log checker is checking. Log checker is nothing but DaemonSet. It's running as a DaemonSet pod. It is checking that as a, it is checking that log file, correct? So so that's it. So if you see, right, the this pod definition doesn't have anything. It just has the name, and it has the spec and the container information and the volume, correct? So you have this application pod, and it is has some external volume mounted. So it's writing to that pod that on the external volume. For this application, it's a path inside the container itself, but that path inside the container is mounted from external volume. We will discuss the volume and all those things in the next, in the subsequent sessions. But this is how this application is writing. Then this daemon pod is running, checking the pod file because it has mounted the same volume in the log file. It's checking the log file and finds those SSN or password. It just logs it. So now what we are going to do is, Let me see if I can create this pod again. I might already be having this pod running, but let's see. CTL get pod. Right. So this is a daemon. Let me delete both the pods. Let me delete every pod. Or before that, I had the daemon set running. So let me delete the daemon set. Kubectl delete daemon set slash monitor, and then I don't have daemon set, and I will have the pod which is related to daemon set deleted. Now let me delete this pod also. Kubectl pod. This is the application pod. I'll delete this as well. Correct. So I don't have any pod running at this moment, and I don't have any um, daemon set also running. Correct. Now let's start. So I will have this pod created. So let's see what this pod is. Or sorry. Sorry. Sorry, what's the name? Pod volume mount. So this is a pod I'm going to create. It doesn't have any label or anything, but this is what it is. Correct. So kubectl create -f. So this pod got created. Now if I say get pods, and I can say show labels also. So there's no label, and this is a pod which is running on this. Correct. So let's go to the next step. And if you see the same pod, right, the volume mount and all those things happening, my home directory on Mac is being mounted as on the temp1 folder inside this pod. Right. Now what I'm going to do is I'm logging to the pod, and just to validate it. So kubectl exec-it, it means interactive, and then and once I log into this pod, I will see ls-ltr/tmp1. This is showing whatever I have on my local Mac. So if I do the same command on local Mac, you will see same files being there. So now I will exit out of this pod. So this pod has been has volume mounted, and now what we'll do is uh, uh, so we'll create a daemon set pod. So I said our labels app name sales on the node. So on the node, this daemon set will run on the, so we'll use the node selector in the daemon set, and the daemon set will have the label called app name equal to sales. So daemon set will look for the nodes with this label app name equal to sales, and any node having this label will get the daemon set pod. So what we are going to do is we are going to get all nodes first. So kubectl get nodes. So let's see, kubectl get nodes. So this is the node, and actually I should have some show labels also. So it had the label or didn't have the label. I'm not able to see. What was the label name? App name equal to sales. I actually had already added it. So if you do not have it, so let's see if I can overwrite this app name equal to sales, and there's a command to overwrite this. So get label nodes, kubectl label node. Let me remove this first. kubectl label node, minikube is the name of my node. Then I will copy paste this, and then hyphen overwrite, hyphen overwrite. OVER, right.
kubectl.
kubectl hyphen override. So now what I'm going to do is I am going to show the labels. Or somehow still showing it. Hold on a second. Label minikube, label node minikube, label node minikube. app name equal to sales and -- overwrite. Try that it should have removed it. -- overwrite. Not labeled, not mini cube, not labeled. Oh, sorry. Get not show labels. Some are still appearing. I think there's some logic in this command, but what I wanted to show you was this. So so now what I'm going to do now is I'm going to create a daemon set, right? So earlier when I was running this before, it didn't have this label. So what I'm going to do now is I will create a daemon set, and the daemon set definition is like this. So you have the API version apps v1 kind daemon set metadata app monitor selector match labels app check security. And why we have given these labels? So that we can use the same label here. This is the same example which I was showing you in the previous one of the previous slide. It's the same. So this is a port template. Metadata labels this. Then I'm creating this a port with this, and here the image I'm giving is the different one. This is a log checker image, and the same volume I'm mounting, right? So let's see that. Unless this is daemon set, right? So I forgot the name of the file. This is the name of the file. So cat daemon set 1. You see it's the same thing which I was showing you, right? So now I'll do a kubectl create -f daemon set 1. So it's created a daemon set, and I can check the daemon set now. Kubectl get daemon set, and it's showing the node selector is equal to app sales. Now, when I didn't have that label on the node, it was showing that desired count is 1, current is 0, ready is 0, and up to date is 0, right? And that's what I was, I had shown here. So it desired it was 0 because it didn't find anything. Current is 0, ready is 0, up to date is 0 because the labels are not matching on any node. Then I change the label. Let me see if I can change the label now. Instead of app name equal to sales, I can give something else. Let's see if that works. App name equal to sales 1. Let's see. Get nodes. Now it's sales 1. Now we'll see what is the value of this daemon set. How this daemon set appears. So now see, there's no desired. This daemon set is not running on any port, right? Now what I'm going to do, and because it has this node selector, and this node doesn't have this same label. So what I'm going to do is I'm going to change the label back of the nodes to sales 1. And now let's check the DS, because now the node has this label app name equal to sales. Now you see the daemon set is running on one node. Incidentally, on our local environment, we have only one node, so that's why it's running on one node only. Right? So now let's do this. So let me clear this out. Now what we are going to do is, so this we validated. Now we see the desired current and ready up to date available count as 1 because that's the number of nodes we have. This pod is running on. And now the question was, if the daemon set is able to select the node using a node selector, then it will be, it will be running for all the pods. So there's no correlation, right? Because daemon set will be a pod in itself. So what we are told daemon set is to do something inside that pod. Now there might be 5 pods, 10 pods, some extra pods, 10 other extra pods running on that node. Daemon set doesn't care what those pods are doing. In our example, what we are expecting those pods to write the logs into certain base log folder, and this daemon set is supposed to take the logs from that base folder and put it into Splunk. So if you have one pod running on the node and you set a daemon set and it's not matching that node, then you will have only one pod running. But let's say you change the label selector, node selector, you change the label in the node and change it to the value which is same as a node selector on the daemon set. The moment you change it, the daemon set will get started on that node, and after that you will see one extra pod is running on that node, and that pod will be for daemon set. So that's how it works. So now what we are going to do is we are going to do a little experimentation, right? So so now we have, if you see the ports, let's check the ports now. kubectl get ports. So now you have two ports running. One is a DaemonSet port and second is your application port, correct? Now, what I'm going to do is I'm going to open the log files. This is the log files which has been DaemonSet has been checking. And what I'm going to do is I'm going to edit this, and I'm going to tell in this file I'm going to tell how to, let me delete this. Sorry. I'm going to tell, I'm going to manually write some words which it is looking for. For example, password and SSN. Correct? So let me do this. Then I will write SSN password. Correct? And I will save this. Correct? Now, if I look at this again, it has SSN password, and this is a file which this is the volume we mounted, and this is the file which our checker is checking. So I will. And how do I know? So the reason I know is because if I go here and let me do one thing. Let me say kubectl exec-it is the image -bash. So I'm logging into the DaemonSet port. So if I go to tmp1 and I look for the file, sorry, let me clear this out and look for this file which I modified, tips.log. So tail -f tips.log. This is what I added, SSN and password. And because this volume is mounted on the DaemonSet, so I can see this in the DaemonSet. This is a DaemonSet, port. I'm logged in there, and this I can see this file there. Now, what I'm going to do is I am going to log into this DaemonSet from other this thing also. kubectl. Now there is on the DaemonSet. On the DaemonSet there is another checker.log. No, 1 second. Let me log it again. And unless you will see checker.log. So I'm going to tail this file checker.log. So now let me tell you what these two files are. The first file where I have written this tips.log, where I have manually entered SSN password. This is a file which is generated by this port. This is an application port. Now there's another port, this is the DaemonSet port. It is going to monitor this file. And the moment it finds some problem there, it is going to log a statement into this checker.log file that I found a problem inside this log file. And what that problem is, it's going to log that problem inside this checker log. Now, how would it do? So what I'm going to do now is I'm going to log into the DaemonSet thing again. We have to invoke that web service for DaemonSet pod. So exec-it this. Okay. So now what I'm going to do is I showed you in the controller, DaemonSet controller, right? Let me show you again. In the DaemonSet controller, I have this /check, and this /check invokes the security checker, and this security checker check this application log file, and the moment it finds password and SSN, it logs into the and that log is into checker.log. So this is what I'm going to show this to you. So I'm going to invoke this service. So the service which I'm going to invoke is curl localhost 8080/check. Because I am on that DaemonSet port anyway, it's easier to invoke from there instead of setting a port forwarding and everything. So I'll invoke this here. So it found, completed yes, and it found this. It found the SSN, and it finds that SSN is found and security is breached. Password is found and security is breached. So that's what it checks, and that's how it logs. I'm just reiterating again. For our crude and wake service, we have been logging it, and we are passing the log file also. We have hard coded the log file. Generally, you pass these as the parameters, and when you find a problem, then you just send alert or notification. Alerts are PagerDuty alerts, notifications are emails or Slack messages and things like this. So that's how it works. That's how DaemonSet works.